2, 1. Go for main engine start. 0 and lift off.
These are not the best of conditions, but for these knights of the highway, hauling a multi-million-dollar spacecraft more than 800 miles is all in a day's work. They're carrying NASA's next planet hunter, TESS. TESS stands for Transiting Exoplanet Survey Satellite. Its job is to search for habitable planets outside our solar system, but close enough to study. That's because we're not just looking for planets, we're looking for life. And the first leg of this spacecraft's journey to orbit is the ride to NASA's Kennedy Space Center.
So we left yesterday at Dulles. We left at 10:15 in the morning. We ran into an accident on 95, horrible weather, rain, down through Richmond.
The 16-hour road trip from Virginia to Florida wasn't easy, and protecting this one-of-a-kind spacecraft during its move was vital. Its shipping container is designed to keep TESS safe on the road.
The case gets used for a number of missions. It's mounted on some shock-absorbing bumpers so that we don't see a lot of the road noise getting into the spacecraft while we transit. We don't want any humidity inside. We don't want the temperature to change, so we have an air conditioning system as well. So we're just trying to keep it environmentally stable on the trip. And then we have very sensitive science instruments. So we actually provide a nitrogen purge. We spray nitrogen gas in to make sure that no air gets in contact with some of the sensitive components.
TESS has safely made it to Kennedy, where it is immediately taken to the Payload Hazardous Servicing Facility. But the job of keeping it clean is far from over.
TESS has really strict contamination control requirements. So what we've done is created a clean enclosure inside the high bay that acts like a clean room within a clean room, basically.
This is a unique mission full of first-time events that are sure to be a challenge.
TESS isn't like another mission. We haven't done another test. This is the first of its kind.
The time has come for this diverse team to put years of planning into practice as they begin the countdown to T0.
We've had a period of hard work that lasted for years, and when we finally get to the point of launch, it's very exciting. This is where the fun begins after we've gotten through all the early legwork and the planning, that we are actually going to now prepare a spacecraft for launch.
Building on the groundbreaking discoveries of the Kepler mission, TESS has scientists across the world excited about its possibilities.
TESS is probably one of the most interesting spacecrafts that I've ever worked on in my career, because of the science it's bringing back down to Earth. It's taking science fiction to science fact.
TESS will use the transit method to hunt for the telltale signs of planets orbiting other stars. In the transit method, the spacecraft watches the sky, and when a planet passes in front of a star, the star's light briefly dims. But Kepler only looked at one portion of the sky. TESS is taking this search to a whole new level.
What TESS is going to do is look around the entire sky around us to find stars nearby, much closer, 10 times closer than Kepler.
The really exciting part about this is it's the first all-sky survey of this type, using the transiting method to look for Earth-sized and super-Earth planets.
I think the real interest by the public in exoplanets is that everyone has a dream that there's an Earth analog out there, another planet that has the ability to have an atmosphere and water and sustain life on it. That, of course, is the ultimate sort of goal of exoplanet science.
When all the pre-launch tests, inspections, cleaning, and checkouts are done, it's time for TESS to join up with its launch vehicle, the SpaceX Falcon 9 rocket. This is a critical process, and it begins with encapsulation. This is the Falcon 9 payload fairing. Its smooth aerodynamic profile will give TESS a safe ride through the extreme heat and pressure of the climb to space. The vehicle systems engineer in NASA's launch
Together, and we have to know how the vehicle operates as a whole. So that's how critical the vehicle system engineer is in this whole process. We've been working very closely with SpaceX from the start, even when during their design phase and going through the whole certification process, the vehicle system engineer was integral in that role to understand what's going on with the SpaceX launch vehicle and how the NASA team can supplement a lot of what's going on.
The fairing is in one piece as it arrives at the door to the high bay Inside, the test spacecraft is ready and waiting for encapsulation.
What's exciting about encapsulation is it's one of the last few things we do to prepare the spacecraft to get ready to go on the launch vehicle. It's exciting because you know we're going to be launching in a few days, which is the most exciting part of working this mission for the past couple of years.
TESS has to be ready for prime time when it gets into orbit, which means the last of its covers used during processing have to come off. Once TESS is inside the fairing, it won't be seen again on Earth. The payload fairing has been opened into two halves, and they're positioned on either side of TESS. The spacecraft is surrounded. Slowly
Lift the spacecraft, the encapsulated spacecraft, onto the trailer, which they'll then transport to the launch site. And from there, they'll make the encapsulated spacecraft to the launch vehicle. And that point, that's the last major thing before we get ready to launch. And that is exciting.
a specialized transporter rolls into the processing facility's high bay. It's here to take the payload fairing and its precious cargo to be attached to the Falcon 9 rocket. Getting TESS to this point was no small feat. It took several teams working closely together to ensure every system and every piece of hardware are ready for this mission. With the crane doing the heavy lifting, the fairing rises off the floor. It's guided with team members helping every inch of the way. The fairing must be attached securely to the transporter for the final miles of its journey on Earth. There is no margin for error. The Falcon 9 rocket is waiting.
The Falcon 9 for the test mission is a new launch vehicle. We are planning to recover the first stage from the test mission on the drone ship, Of Course I Still Love You. If successful, this will be the 24th successful booster landing for SpaceX. By recovering first stages, not only do we understand more about our launch vehicle, it also enables us to reuse and refly that hardware, which is a key part of the SpaceX mission.
The fully assembled Falcon 9 rocket, with TESS on board, rolls out of the hangar at Space Launch Complex 40 at Cape Canaveral Air Force Station. Its final stop, the launch pad.
The SpaceX team is really proud to be part of such a cool mission, the TESS mission. The TESS satellite is looking for planets outside of our solar system in our galaxy, which aligns very well with the SpaceX vision to make life multiplanetary. To prepare for the rocket to be vertical on the pad today, the engineering team in the hangar did those final last checks. We mated the fairing to the rocket, and once the launch vehicle was finally checked out, the rocket rolled out of the hangar late last night and went vertical early this morning.
TESS is healthy. The Falcon 9 rocket stands ready. It's time for the final countdown.
So launch day is a pretty incredible day. Those last few minutes, you're just holding your breath. You find yourself holding your breath until, you get that T0 count. I lead a team of LSP engineers to successfully launch our spacecraft into orbit.
The SpaceX team has partnered with the NASA Launch Services Program, NASA Goddard, Orbital ATK, and MIT to enable that planet-finding mission.
We go on console about maybe 3.5 to 4 hours prior to launch. We do our voice checks to make sure we can activate and we have all the voice channels that we need to listen. We're listening to at any one point in time, maybe 6, 7 voice channels at the same time, so you're kind of training your ears to listen for your call sign. The team has a great responsibility to be able to look at all this data and say, yes, we are go for launch.
LD, go for launch. Falcon 9's in startup. Falcon 9 is configured for flight.
3, 2, 1, 0. Liftoff. The SpaceX Falcon 9 carrying TESS.
Status check to proceed with terminal count.
There is a moment at the start of every mission when everything comes together. A moment when years of preparation and planning are put to the test.
Clear to proceed.
There are no second chances.
You have permission to launch.
Success or failure is just a heartbeat away.
Rock report range status. Range green.
A spacecraft and its rocket on the pad, fully fueled and ready to launch.
Status check. Go Atlas. Go Centaur.
In that moment, a controlled explosion is released with such intense power it can propel a spacecraft off the Earth and into space for the benefit of all. We call this moment T0. This is its story.
NASA's InSight, the first
NASA is about to do something we've never done before. Nestled along the mountains on California's Central Coast is a little talked about space launch center known as Vandenberg Air Force Base. From here, history is about to be made.
This is the first time we've had an interplanetary launch from Vandenberg Air Force Base in California. The cool thing about this launch is that we've got such a capable rocket, the Atlas V, we don't have to launch from Florida.
InSight is going to be the first time we've had a spacecraft leave Earth's orbit launching from California. We've actually done studies for it even up to decades ago, but it just comes down to whether or not the mission had extra propellant left over and whether there was an operational reason to switch from an East Coast launch to a West Coast. This is just the first time all of it came together.
What we're going to do is we're going to unload the spacecraft really, really carefully, and then we're going to drive it a couple of miles to the Astrotech facility where they have a clean room all set up for us. Got about 2 months here. All we got to do is clean it up, test it out, put the fuel in the tanks.
Using probes and seismometers, InSight will listen for Mars quakes and measure how much heat the planet's interior gives off. If we're going to truly understand how rocky planets like Mars and Earth were created, we need to look inside.
It's unlike other missions that we've done to Mars. We have a number of orbiters, a number of landers that we've successfully explored this amazing planet. But this actually is the first mission where we're really looking on the inside, the inner space of Mars.
Sending a science mission to the Red Planet is never easy. Landing a probe on the surface is even harder. To accomplish this, InSight will have to shed its many components in a matter of minutes, bit by bit, like peeling an orange, until only the lander is left.
So the crew stage itself is the critical component that actually gets us to Mars. There's an aeroshell that absorbs the heat as we re-enter the atmosphere. That aeroshell enables us to go through the atmosphere of Mars successfully without getting the inside, the lander itself, too hot. We deploy a parachute. That parachute does two things. It really ensures the stability of the aeroshell as it's starting to get closer to the surface. It also slows down the spacecraft further until finally we drop out of the combination backshell and parachute, and then we do a propulsive descent down to the surface.
We know water exists on Mars, and where there's water, there could be signs of life. But we must ensure any organisms we discover weren't simply stowaways from Earth. This is where the Planetary Protection Team comes into play.
Planetary protection is what we do to responsibly explore other planets and moons in our solar system. In order to do that, we need to make sure that we send a clean spacecraft there. We would hate to get to another planet or moon and think we discovered life, but it was actually something that we brought with us. So we collect our samples on InSight, any part of InSight that's going to land on the surface of Mars. We bring it back to our lab and we process it using a NASA procedure. If we run into a situation where we take a sample and it comes back as having a higher number of bacteria than what we want, then we make sure that the engineers go back and clean those surfaces with the whole idea that we don't want to cloud our ability to potentially find life on another planet or moon.
Lockheed Martin Space of Denver, Colorado, built InSight with an extremely efficient design, streamlining what needs to be done at the launch site. They shipped the spacecraft to Vandenberg with no assembly required. Simply check it out, fuel it, test it, encapsulate it, and it's ready for launch.
The processing for our spacecraft has been very smooth. A lot of the processing had to do with fueling the spacecraft, removing some remove before flight items. Everything else was pretty much already installed on the spacecraft in Denver, Colorado before it was shipped here. And that's called a ship and shoot, which means there's not too much to do except for to fuel the vehicle and do some last-minute power-on checkouts of the onboard computers and subsystems.
These preparations are crucial. Everything must be working perfectly before InSight leaves Earth. This effort is designed to ensure a safe arrival and landing following the 6-month trip from Earth to Mars. In the meantime, United Launch Alliance, or ULA, is busy at their launch pad, Slick 3, assembling the world's most successful rocket, the Atlas V.
Well, I mean, we're building a rocket. What's not exciting about that? And really excited to be able to launch the first planetary mission from the West Coast.
First, ULA stacks their Atlas V booster onto the launch platform. Atlas V is powered by the mighty RD-180 rocket engine. The RD-180 is a powerhouse, burning highly refined kerosene known as RP-1 and liquid oxygen for thrust. For this mission, the RD-180 has more than enough power to get InSight off of Earth and heading towards Mars. When the booster's fuel is spent, the Centaur second stage kicks in and finishes the job. Centaur won't actually hit Mars. It will fly just past it. Final course corrections will be done by InSight itself to enter the Martian atmosphere and land on the surface. Once fueling and testing is complete, the team from United Launch Alliance will encapsulate InSight inside its payload fairing, the shell that keeps InSight clean and safe during its dangerous ascent through Earth's atmosphere.
We're at the phase of the mission where we're encapsulating with the launch vehicle, and the ULA team with their fairings now come in and they take the two halves of the fairings and they make a clamshell around the spacecraft to help protect it for the environments that we see during launch. And we do that because as we leave the Earth's atmosphere, the air and the molecules in the atmosphere would tear up our spacecraft otherwise, and the fairing is there to protect us.
With InSight encapsulated in its fairing, it's time to move the payload out to Slick 3. But this California coastline comes with its own set of challenges. The surrounding marine layer can swallow up a launch pad, reducing visibility to under a couple hundred feet.
So right now, it's on the transport vehicle and it's ready to roll. And we'll be rolling out around 2 a.m. At that point, we'll have a convoy that drives very slowly from the payload processing facility out to the Slick 3 Atlas V.
This morning when it was sitting on the truck and they put the crane on it, they started lifting it up. That's the last time this spacecraft's ever going to feel the ground of Earth. I'm just kind of jumping out of my skin. This is so exciting. We're getting so close to launch, and it's been a long, long road for me. This has been a challenging program. I mean, we've had a lot of technical issues. We really feel really confident about this launch now. We got it on top of the rocket. We're going to blast it off in just a few days, and when it gets to Mars and lands, finally it will have solid ground under its feet again and get to work on probing the depths of Mars.
But InSight won't be traveling alone. Hitching a ride to the Red Planet are a pair of CubeSats, twin satellites called Marco A and Marco B.
So Marco is a dual payload riding as a secondary mission on its way to Mars.
So Marco is a pair of CubeSats, and CubeSats are really small spacecraft. They're essentially the size of a large cereal box, so about this big.
It's going to be relaying telemetry from the entry, descent, and landing of InSight back to Earth in near real time. After InSight is deployed on orbit and is heading to Mars, Centaur, which is behind me, ejects Marco A into orbit, and it'll slowly rotate itself so that Marco B ejects 180 degrees on the other side of the vehicle.
But Marco is a technology demonstration mission. It's actually one of the smallest spacecraft we've ever launched to interplanetary space. It's the first interplanetary CubeSat. So in of itself, it has all of these technology that we've never tested in deep space before. So if Marco works this time, one of the cool things that we could do is actually replicate that system and fly it with other missions in the future. And whether you're going to Mars or Venus or maybe even further away to an asteroid, you could think of it as bring your own telecom relay.
So everything went well today with the lift of the spacecraft and mate onto the rocket. It started off very foggy and windy, and right now it's a beautiful day, just typical California weather. And now we're ready to go to Mars.
Last until daybreak.
As we get closer to T0 liftoff time, a number of activities have to happen. There's a mobile service tower around the Atlas V rocket, and the InSight spacecraft is on top of the rocket, enclosed in the payload fairing. So we're going to back that mobile service tower away from the rocket to leave it exposed just beside the umbilical tower.
Stand engineer, proceed with MST roll to park position. Roger. MST bores shall be closed in park position. Roger.
The final launch pad preparation is underway. Once the mobile service tower is rolled back, InSight and Atlas V are just hours away from T0. Basking in the searchlights of the West Coast facility, they are presented with the glamour of a Hollywood premiere.
The launch team about the InSight mission. First time we're going to launch from the California coast, going to Mars. And what is really exciting to the team is this is the culmination of a lot of work. The teams have been working on this mission for over 5 years, and today is the day that they will see all of their hard work rewarded.
Status check to proceed with terminal count. Atlas Systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur Systems. Propulsion.
Go.
Pneumatics.
Go.
LH2.
Go.
Facility.
Go.
Range coordinator.
Clear to proceed.
Launch director.
LCU. 5, 4, 3, 2, 0. Liftoff of the Atlas V. Launching the first interplanetary mission from the West Coast. And NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
Seconds after liftoff, the rocket punches through the marine layer, lighting the night sky for miles, visible all the way down to Los Angeles. An infrared camera showing the long tail of the exhaust plume captures some of the ascent, as well as an onboard ascent camera.
And we're nearing booster engine cutoff, or BECO.
Back to 4.6 Gs in preparation for BECO. Boost phase cooldown has completed. And we have BECO. Shutdown looks good. Stage separation. We have box and fuel pre-start. GN2 purge firing. The RCS is underway. We have ignition and full thrust.
The RL-10C engine, the second stage of the Centaur,